Hello, ladies and gentlemen. We start chapter 19. This is part number 1. And I would like to say that since section 19.1 is a very descriptive section, it describes properties of transition metals, also their preparation and their compounds. Therefore, I would like you to review this section by yourself. When we talk about transition metals, what we have in our mind are so-called D like Denny, D block metals. Why? Because they will fill orbitals D. You know about electron configuration, you know about orbitals D from Gen Chem 1, so I don't have to add anything here. Please read about the properties of those metals. This is a table that shows just basic properties like first ionization energy, bond, atomic radius, density, melting point. Of course, do not even think about memorizing all those values if needed. Values like this can be always given to you. You might remember from General Chemistry 1 when we look at atomic radius of an atom, we had some nice changes from group to group, but only when we were talking about main groups of the periodic table. When we look at the atomic radius for these transition metals, then as you can see, we will have some changes that will not really follow a general pattern. However, in general, atomic size increases down the group. We know that because we will have more electrons. So if we go down the group from the let's say from here, right, our metals down here, the atomic radius will increase because we will have more electrons. And now, ladies and gentlemen, right now it is extremely important that you know electron configuration for transition metals, not only electron configuration for metals themselves, but also for their ions. So just to give you an example, ladies and gentlemen, this is iron. I will, if I ask you to write electron configuration, I will ask you for the full electron configuration. Here, this is an abbreviated version. So we have the configuration of argon. And then, ladies and gentlemen, we have 4s2 and 3d6. This is how you see those electrons in the periodic table. What happens if we remove 2 electrons and we form a +2 cation? Which electrons are lost first? Ladies and gentlemen, always 4s electrons will be lost first. In this case, we lose 2 electrons because we form iron 2 plus cation. So these 2 electrons will be lost and our iron 2 plus will have this electron configuration. The fact that we have d electrons is responsible for some important properties. Transition metals have more than one oxidation state. Transition metal compounds will be characterized by different colors because we will have some electronic transitions there. We'll talk about this in part number 3 of this section, of this chapter. And transition metal compounds, many of them will have magnetic properties. Again, part number 3 of chapter 19 will address not only electronic transitions that cause colors in these compounds, but also their magnetic properties. So, ladies and gentlemen, write the full electron configuration of vanadium. Full electron configuration means, ladies and gentlemen, we start with 1s2 and of course 4s2 and 3d3. This is what we see from the periodic table. So whenever you are asked for electron configuration, make sure that you have periodic table in front of you. What about chromium, ladies and gentlemen? Well, chromium, if we would write this electron configuration in a way we did for vanadium, we would have 4s2, 3d3. But you probably remember from General Chemistry 1 that this is one of the exceptions, because 5 electrons on orbital D's or orbitals D means that there will be 1 electron on each orbital D, right? There are 5D orbitals for each main quantum group. So this is a very preferred configuration. Therefore, ladies and gentlemen, instead of 4s2, 3d4, this configuration brings us lower energy, so preferred situation, when 1 electron from orbital s is, well, for a lack of better word, promoted to orbital d, and this is one of the exceptions from the rules. The other exception is when we have 9 s2 d9, then 1 electron is promoted here and we have s1 d10. All right. Okay, so we are done with atoms. What about ions? Let's go back to vanadium. And right now I want full electron configuration for V2+. So what do we have? These are our last electrons. So which electrons will be removed first? Always these 4s electrons will be lost first. So since we are forming V2 plus ion, these 2 electrons will be lost, and this will be electron configuration for our V2 plus cation. Of course, if we have V3 plus, 2 electrons go from here and 1 electron is lost from orbital D. So that's the only thing that I wanted to comment on. By the way, all oxidation states for metals, including transition metals, are positive. The most common oxidation state is +2, but we also have +1, +3. All possible positive oxidation states. The maximum common oxidation state is +7 for manganese. So +7 will be the highest oxidation state for transition metals. +1 is for copper. So really the oxidation numbers change from +1 to +7 here. So ladies and gentlemen, as I said, please read section 19.1 in your textbook. This is a very, very short recording, and there will be more in the part 2 and part 3 of chapter 19.